Good afternoon, everyone. So I'm going to talk a bit about what we can do to try to address the issues of fatigue and what the body of research shows around fatigue interventions, particularly focused in manufacturing and warehousing industries. These industries present a unique opportunity to intervene in that we often have controlled work environments where we can implement set schedules, and we also have the case of workers across multiple shifts where we're going to need to address some of the physical challenges for a range of employees and shift schedules. So we want to think about what types of interventions are available. And if we think to our overall structure of safety interventions, we can think about our typical categorizations of interventions. The first level being administrative versus engineering controls, where with engineering controls, we're changing the task and how the task is performed. With administrative, we're changing more the structure of the work environment and the schedules and policies around the physical tasks that may be leading to fatigue. You can also think at the individual versus the workplace level. So are we putting in strategies for one person, or are we changing maybe the workstation or the work components to resolve the issues for multiple people at once? And then thinking in time scale, looking at being preventive, so minimizing the likelihood of fatigue developing, or reactive. Do we want interventions that are going to be implementable once someone has become fatigued? And I would recommend that we have interventions and those ready in the workplace to look at all of these levels. So have some things that are done to prevent fatigue, but then also have some solutions ready if fatigue does occur. And if we think of our typical safety hierarchy of controls, for most work tasks, it's difficult to be at the top level of eliminating the causes of fatigue, but this would be our ideal strategy. Instead, we're often down a few levels, looking at our engineering controls, our administrative controls, and then the personal protective approach. Now, if we think as with other safety interventions like hearing protection, we often say that engineering controls to be more effective long-term, personal protective, usually a necessary add-on component, but not a solution all unto their own. So if we think about the solution to physical fatigue, often have to think about it as a systems approach, within that hierarchy. So we might implement an engineering control of reorganizing or redesigning the work, where we reduce some of the physical fatigue risk factors like repetitive motions and excessive forces. Then we add in an administrative control of providing ergonomic consultations to workers so that they can have a workstation that works best for them. And also looking at the profile or demographics of the workforce to provide the employees with self-management strategies that they may be able to implement both at work and once they leave work for the day. So each of these on their own may not address the problem of physical fatigue, but together we can have a cohesive solution. So now we'll go into a few specific interventions in the literature or the research that's supporting these intervention types. And the first is at the individual level, looking at exercise and well-being. And the thought here is that if you have healthy individuals who are physically active, that they are more likely or less likely to develop fatigue, so more resistant to fatigue. But if we look across industries, as each of these bars is, we can see that in no industry do we really have more than half of the population meeting the exercise recommendations set out by the CDC, and then each is hovering around 40 to 50%. Now, the reason that this is important or maybe problematic if they're not getting the right level of exercise is that there's some support to show that in this case for a 6-week exercise trial where workers were exercising at least 3 days per week, the overall fatigue ratings on a subjective scale were less. And so workers reported feeling better after they participated in this exercise program. Now, In addition to general activity and motion, there's also the thought of adding some variability or activity into the work task performance as well. Because if we maintain a sedentary or a static position throughout the day, that can lead to discomfort developing and muscle fatigue across certain different parts of the body. And so in this study shown in this graph, for those who added in short periods of standing and activity over the course of the day, they also reported lower levels of total fatigue, whereas those who were sedentary for the full day had these higher total fatigue scores. So prolonged standing, we know, can lead to leg discomfort after just about 45 minutes of standing or walking. And they've reported similar results for the low back, knee, and ankles and feet. So while the general media has talked about minimizing sedentary work, we also want to minimize any sustained standing posture. So that really encourages us to have a more variable approach where we're adding in movement throughout the day, but we do not yet have evidence on the optimal durations for the break periods and how often we should be switching back and forth. Now, another strategy for trying to add some variability is implementing anti-fatigue mats into the workplace. There is some research that supports lower levels of discomfort when using the anti-fatigue mats. However, the mats themselves are not a solution. They are part of this overall strategy towards fatigue intervention. And similarly, adding in worker education and looking at hiring appropriate workers for the job is an important component to or countermeasure to minimizing the risk of fatigue. But we don't really have any evidence on the specific effectiveness of these countermeasures. At the work level, right, we can then look at adding in rest breaks and varying the task to naturally add in some of that posture variability throughout the day. The benefit be to allow for the muscles and joints to have some periods of break so that we can recover or transfer the activity that's being done to multiple muscles across the day so that we are not overloading any one. And this can be done through work rest cycles where we have evidence to support short rest breaks that are spaced throughout the day, and we'll get to that in more detail on the next slide. You can also want to decrease the number of static or sustained loads that the person is required to support, because those sustained loads don't allow for the muscles to get any break, and we often cut off the oxygen supply and blood supply to the muscle that allows it to maintain the muscle force. And so we want to think about ways in which to reduce static loads by supporting the body segments. Most of the weight done at work, other than in maybe very heavy materials handling, is actually from supporting the weight of the body. So if you're holding a small hand tool, the tool itself maybe weighs 1 to 2 pounds, but if you have to hold that out in front of your body, your arm weighs about 5% of your body weight. So your shoulder has to support that arm weight plus the tool weight. So if we can add body segment supports like arm rests, then that can reduce some of that load. And then also add in tool supports so that the weight of any light tool or even heavier tools is taken off. Now, our traditional approach in a manufacturing environment to allocating rest allowances has been to look at a % of the total time and working that into the standard time allotted for the cycle. This has been used in very repetitive tasks where we have a fixed cycle time maybe on the order of 2 to 5 minutes, right, where we say maybe 5% is going to be a basic fatigue allowance. Now that, as I mentioned, requires a fixed task and fixed work cycles, which may not be present in a lot of workplaces. And it also fails to account for any task dependency or baseline conditions and any individual factors that may require different accommodations or allowances for different people. Now, the concern management often has in implementing rest breaks is that it's non-productive time for the workers, but fatigue symptoms have been shown to be reduced with the introduction of added short rest breaks, and that can then lead to improved productivity long term. And the rest break doesn't necessarily need to be an added period of break. So if we're adding in short rest breaks, these can be spaced as part of the cycle time, where you build a 2-minute cycle time to have maybe 15 or 20 seconds each cycle of rest so that the worker gets those short micro breaks. So some general rules of thumb is to, for high exertion tasks, lower the duration of the task and provide frequent breaks. For low exertion tasks, you get more benefit in terms of endurance and fatigue prevention by reducing the work intensity, because we have somewhat of an exponential curve where the endurance time greatly increases at those very low ends of the work intensity cycle. So how do we choose what are the best and most appropriate interventions that we want to implement? And we really have to start by understanding who the workers are. What are their characteristics in terms of their demographics? Do we have an older workforce that may be more susceptible to or have more difficulty doing high force tasks? What are the strength capabilities of our workers if we have that information from functional capacity evaluations? And what is the variability within the workforce? Do we have a good mix of male and female workers, or do we have more towards one? Do we have mostly older workers, or do we have a large range from 18 to 65? And we can look at our injury data and see from the injuries what type of injuries are occurring most often. So are they shoulder-based, back-based, distal upper extremity? And that can help us pinpoint what type of fatigue is present. And then we want to think about the tasks that are being performed for those who are becoming fatigued. So are they doing repetitive work, or is it forceful exertions? And this will let us focus our assessments and understand where we need to intervene. And then we want to think about where in terms of the work environment, the environmental factors that may be contributing to the fatigue development. So if we have hot environments that or low light environments that may be contributing to it. And it may not all be in manufacturing shop floor workers that are experiencing the problems. It may be those in the office staff. And then we can think about the impacts of sedentary work for those individuals. Then we want to figure out which tools we can use in order to document the problems of fatigue that we're having and come up with any redesigns and how we're going to evaluate those redesigns. We want to choose appropriate tools that are going to provide us with the information and the data that we need to support our decision making. So as a first step, we want to talk to the workers, understand their tasks, understand the types of discomfort that they're having, and any feelings of fatigue that they might be experiencing. So this can be done with questionnaires or interviews, and we can talk across a range of employees, across the schedules, across the shifts, and across the workstations to understand what the range of symptoms might be. And we want to know when they're experiencing the symptoms. Is it at the start of a shift? Is it on a Friday afternoon? Is there any variability in what they're experiencing? This will allow us to understand that we do have a fatigue problem and identify and diagnose what type of problem it is, because we want to target the intervention to the specific type and location, as well as the root cause of that problem. Then we're going to gather some data on the tasks and on the worker responses, see to kind of balance out that subjective data that we have from talking to the workers. And this can be done by real-time observation of the operators to see if they're changing their behavior and whether they are adopting new strategies in order to compensate for any discomfort or feelings of fatigue. Or we can look at performance-based monitoring, where we're seeing if there are any reductions in task performance over the course of shifts or across weeks. These interventions are how we might target physical fatigue, and now Dr.